Researchers found that a person in a particular country spent an average of 4.1 hours a day watching TV in 2010. Assume the population standard deviation is 1.6 hours per day. A sample of 33 people averaged 4.9 hours of television viewing per day. Does this result support the findings of the study? So we can actually use the central limit theorem to test claims. And the idea is you can use a sampling distribution to see how unusual a sample result is if the claim is true. If the sample result is very unusual, we conclude that the claim is not valid. So if you look at this problem, if the probability is less than 0.05, then the result is not going to support the study. So we're looking at a probability of it being highly unlikely or result. And if it is greater than 0.05, then it does support the findings of the study. So let's just look at it. Basically, you are going to work this like you normally would. You're going to get your z-score, and then you're going to go look up the probability. So let's work it together just to make sure that you understand. So I have written all our information down, and it looks like our sample size is large enough. Even if it is not normally distributed, we can use our central limit theorem rule, which says that the mean is equal to the mean of the average means, or the mean of the sample means is what I meant. So that's going to equal 4.1. Okay, so let's do our standard error over mean just like we normally do. The standard deviation divided by the square root of n. So the standard deviation is 1.6 hours, and we have a sample of 33, and we're going to get that and round to 2 decimal places. So we get 0.28, and now we're going to do we're going to calculate our z value for our sample mean, which is going to be our sample mean of 4.9 minus 4.1 divided by 0.28, and let's see what our z value is. We get 2.86. Okay, now we want to test the claim that people spend at least 4.9 hours. So at least means we want it to be, see what the probability of the mean being more than 4.9, because that's going to be the average. And so we're going to do we're going to go in Excel and get the value of 2.86 and see what that is. Now that's going to be your less than. So we're going to have to find the greater than side. Okay, so the greater than side is 0.002. Okay, 0.002. And since that probability is less than 0.05, the result does not support the findings from the study.